Hello everyone. In this video I'm going to go through the solution to the regression exercise. As always, if you haven't attempted the problem yet, I recommend you stop the video now and try the problem. For this you'll need to download the Excel file called CEO and make sure you have your data analysis tool pack enabled. I've loaded up our dataset. Each observation in this dataset is a CEO of a company. We have their salary in dollars, age in years, their tenure as CEO, that is how long they've been serving in that role in years, and the company's sales in millions of dollars. The first thing we are going to do is run a regression of salary on age, tenure, and sales. To do that, I'm going to pull up the data analysis tool pack, select regression. For the Y range, as always, that is going to be our left-hand side dependent variable, that is salary. For the X range, that's our explanatory variable, so I'm going to select the entire block of data of age, CEO, tenure, and sales. Make sure that we select labels since we do have that top row selected. Click OK to run the regression. Are right here in the coefficient column. Putting all these together, we can write out our estimated equation, which will be salary hat equals first our intercept plus 661.48 times age plus 13,653 times CEO tenure plus 3766 times sales. If we had a new CEO come along and we knew their age, tenure, and sales of their company, we could then plug these in to make a prediction of what we think on average their salary would be. Next, we are going to do some hypothesis tests. For the first test, we are going to determine the statistical significance of CEO tenure. Remember from the earlier videos this week that a test for statistical significance is a test where the null hypothesis is that the coefficient is 0. To calculate the t-stat for this, we are going to take our estimate minus the null, which is 0, and divide that by the standard error. We get 2.24, and you can see that this is actually the exact same t-stat that we see right here in the regression output. These t-stats that you see in the table are always for the test that each of those coefficients is 0. CEO tenure is statistically significant with 90% confidence because 2.24 exceeds 1.65. It's also statistically significant with 95% confidence because it exceeds 1.96. But since it does not exceed 2.58, we cannot say that CEO tenure is statistically significant with 99% confidence. Said another way, we cannot reject the null hypothesis that beta 2 is 0. With 99% confidence, but we can with 90 and 95%. Finally, we are going to do a test for the null hypothesis that an increase of $1 million in sales is going to increase our CEO's salary by $50. Remember that the sales variable is already in millions, so really we're just talking about the slope here. To state our null hypothesis, we're simply saying beta 3 equals 50. Let's now construct our t-stat. As always, we're going to take our coefficient estimate, subtract our null hypothesis value, which is 50, and divide that by the standard error. We're going to get negative 1.82. We take the absolute value of that, which is just 1.82, and then compare that with our critical values. Since this is bigger than 1.65, we can reject the null that the effect is $50 with 90% confidence. but it is not bigger than 1.96, which means we cannot reject this null with 95% confidence, and of course we can't reject it with 99% confidence either. To wrap up, when doing a hypothesis test, you have to make sure we're going through all the steps. Stating the null, in our case, beta 3 equals 50. Stating the alternative, beta 3 is not 50. Calculating our t-stat, and then determining whether or not we can reject or not reject our hypothesis. If you have any questions about what we just did here, please let me know. Thanks for watching.